Hello, my name is Zachary Walk and welcome to my video surrounding the concept of series and parallel circuits within the UOW subject and 104 electrical systems. Firstly, it is important to understand the fundamental elements that are incorporated within both series and parallel circuits. We have the power source, which is known as a voltage source and is measured in volts. Then we have a resistor which reduces the current flow within the circuit and is measured in ohms. And one more important element that is required, otherwise the circuit will not work, is a ground, which is a reference point for the respective circuit. A basic circuit is built with a battery, a resistor, a ground, and is connected with a wire. For a series circuit, as you can see on the left, there is a fault. If there is a fault within any element, the entire circuit will break. However, within a parallel circuit on the right, if an element in a branch has a fault, then only that branch will fail, but the rest of the circuit will remain working. Now, we have a simple series circuit that contains two resistors. We are able to calculate both the total resistance and the current that is within that circuit. It is important to note that the Ohm's law is very significant within circuits. It states that an electrical circuit is proportional to voltage and inversely proportional to resistance. To find total resistance, you have to sum all the resistances together. So for this example, it would be 5 plus 7 ohms, which is equal to 12 ohms. Then using this, we can now calculate the current by using Ohm's law. We divide 12 volts by 12 ohms to get a current which is 1 amp. Moving on to parallel circuits, as you can see in the example, there is a circle which has two arrows coming from it. This identifies that the current splits at what is known as a nodal point. The current within a parallel circuit is different to that in a series circuit and is broken up across the circuit depending on the resistance in that branch. However, the current will always sum back together before going back into the supply. For resistors in parallel, the overall resistance is the reciprocal of the sum of reciprocals of the individual resistors. That is, in this example, 1 over 5 plus 1 over 7 plus 1 over 9, which is all to the power of negative 1. This results in 2.2 ohms. Using that value, we can then calculate the total current within this circuit, which will be equal to 12 volts over 2.2 ohms, which is equal to 5.45 amps. However, this 5.45 amps is only the total, and each branch pulls a certain amount of the 5.45 amps, which also can be calculated. Now, using multisim, we can verify and confirm our findings for both series and parallel circuits. This is my short video on series and parallel